Given the middle points of the sides of a triangle ABC, let us consider the triangle ABC here with the vertices A, B and C, and the midpoints of this triangle, say BC midpoint is D and CA midpoint is E and AB midpoint is F. So that there is a triangle DEF and the position vectors are given. OA is equal to I plus J plus 0k and OB is equal to 0I plus J plus k and OC is equal to k plus a, that is I plus 0j plus 1k. So from here, since D is a midpoint, we can write OD vector is equal to OB plus OC upon 2. So we can write OB vector plus OC, that is 0 plus 1, that is 1i, plus 1 plus 0, that is I 1j, and 1 plus 1, that is 2k, divided by 2, and OE vector is equal to, it's a midpoint of the points A and C, so we can write OA plus OC by 2, OA vector plus OC vector, so we can see here 1 plus 1, that is 2i, and 0 plus 1, that is 1j, and 1 plus 0, that is 1k, divided by 2, and OF vector is equal to, it's a midpoint of 2 points A and B, so we can write OA vector plus OB vector divided by 2. So OA vector is I and OB vector, so 1 plus 0 is 1 and 1 plus, that is 2j, and 0 plus 1, that is 1k, divided by 2. And now since we need the center of triangle DEF, so we can write, let us consider G be the point center, then the vertex or the vector OG can be taken as OD plus OE plus OF upon 3. So we can write 1 by 3 times of OD vector, or 1 by 2 is taken common here again, 1 by 2 times of OD vector, and 1 plus 2i, that is 3i, plus 1i, that is 4i, 1j plus 1j, 2j plus 2j, that is 4 times j, 2k plus 1k, 3k plus 1k, that is 4 times k, which is equal to 1 upon 6 into 4 times of again I plus j plus k, that is 2 times, and here 3 times. So we can write 2 by 3 times of I plus j plus k. So which is our option D. And here we have taken 1 upon 3 times since it is a centroid. Centroid formula is 1 by 3 times of the sum of the vertices. So we can say OD plus OE plus OF upon 3. So the answer is option D. Given two vectors A and B such that mod of A plus B is equal to mod of A minus B, and we need to find the angle between the two vectors A and B. Basically, when two vectors are given, vector A and vector B, and let's take the parallelogram defined on these two vectors. So we can get the two diagonals. One diagonal can be considered as A plus B, and the other diagonal we can consider, other diagonal can be taken as A minus B. Since the two diagonals are same, the length of the diagonals are same, we can consider that this parallelogram can be a rectangle, and hence angle between A and B is 90 degrees. So we can go with an option B. Let us find by mathematically squaring on both sides. Mod of A plus B whole square is equal to mod of A minus B whole square. So we can write mod A square mod B square plus 2 times of A dot B is equal to mod A square plus mod B square minus 2 times of A dot B. Mod A square both sides gets cancelled here, and mod B square also. So here 2 times of A dot B and here minus 2 times of A dot B, bringing one side we can get 4 times of A dot B is equal to 0. So we can write A dot B as mod A into mod B into cos of the angle between them. So let us consider theta be the angle between two vectors A and B. So we can write theta here. So now which is equal to 0. So 4 mod A mod B are constants, cannot be 0 here. So which implies cos theta is 0. Cos theta is 0 when theta is equal to 90 degrees. So and hence we can say that angle between these two vectors is 90 degrees, which is option B. Given that A cross B whole square plus A dot B whole square is equal to 676 and mod B is equal to 2. A cross B whole square, which can be taken as mod A into mod B, let theta be the angle between A and B vectors. So we can write sin theta into the unit vector whole square. So which can be taken mod A square mod B square and sin square theta into n cap square. N cap square we can write mod n cap whole square, that is 1. Since n cap is a unit vector and hence we can consider it to be 1. Similarly, A dot B whole square is equal to mod A into mod B cos of the angle theta between them whole square, which is mod A square mod B square cos square theta. By adding these both, we get an identity mod A cross B whole square plus A dot B whole square is equal to mod A square mod B square is common. So we can write sin square theta plus cos square theta, which is 1. So we can write mod A square into mod B square. And since it is given A cross B whole square plus A dot B whole square is 676. So 676 is equal to mod A square into mod B square, or we can write 676 upon mod B square. Mod B is 2, 2 square is 4, so which is equal to mod A square. So 4 ones are 4, and again here 169. So mod A square is equal to 169, which implies mod A is equal to 13. So we can go with an option A, 13 is the answer. We need to find out the unit vector perpendicular to both the vectors A and B. Unit vector perpendicular to both vectors A and B can be taken as A cross B plus or minus under divided by mod of A cross B. So let us find A cross B. The first row ijk and second row the components of vector A minus 1, 1 and 1, and in the third row we can take the components of B 1, minus 1 and 1. So after simplifying, we get I times of 1 plus 1, that is 2, minus j times of minus 1 that is negative 2, plus k times of 1 minus 1 that is 0. So we can write 2 times I cap plus 2 times j cap plus 0 k cap. Now mod of a cross b is equal to under root of 2 square plus 2 square plus 0, which is 4 plus 4 8, that is 2 root 2. Now the required unit vector perpendicular to both the vectors a and b is given by plus or minus a cross b divided by mod of a cross b, which is equal to plus or minus 2i, or 2 taken common, I plus j, or here we can write 2 times of I plus j plus 0 k divided by mod of a cross b is 2 root 2. So we can say here I plus j divided by root 2 plus or minus. So among the options, if we can see, so option A plus times 1 of I plus j upon root 2. So we can go with an option A. With respect to a rectangular Cartesian coordinate system, three vectors are expressed. Vector A is given 4i minus j, and vector B is given minus 3i plus 2j, and vector C is given minus k, that is 0i plus 0j minus 1 times of k. And now, where I, j, k are the unit vectors along the x-axis, y-axis and z-axis respectively, and we need the unit vector p along the direction of sum of these vectors. So let us find the sum of these vectors. A vector plus b vector plus c vector is equal to, we can get 4i minus 3i plus 0. These are the sum of I components. And similarly, the next one, j minus 1 and 2 and plus 0 j component, and then k 0 plus 0 minus k. So we can add 0 plus 0 minus 1 of k cap. So which is equal to 4 minus 3, that is 1 times I, and 2 minus 1 is plus 1 times of j, and this is minus 1 times of k. So we got the vector I plus j minus k, and since we required the unit vector, so p is equal to, so we may consider plus or minus I plus j minus k divided by mod of this vector, that is plus or minus I plus j minus k upon under root of 1 square plus 1 square plus minus 1 whole square, that is plus or minus I plus j minus k upon under root of 3. So 1 by 3 plus or minus 1 by 3 I plus j minus k. So we can go with an option A. Option A is the answer. If the position vectors of the vertices ABC of triangle ABC given as OA is equal to 0i plus 7j plus 10k, and OB is equal to minus I plus 6j plus 6k, and OC vector is equal to minus 4i plus 9j plus 6k respectively, and we need to identify whether what type of triangle it is. So let us find the length of the side. So side vectors AB vector is equal to OB minus OA we can write, which is equal to minus 1 minus 0, that is minus I, 6 minus 7, that is minus J, and 6 minus 10, that is minus 4K. And BC vector we can write OC minus OB, OC minus OB here, these both. So minus 4 minus of minus plus 1, that is minus 4 plus 1 of I, and 9 minus 6 of J, and 6 minus 6 of K. So we can write BC vector is equal to minus 3I plus 3J and again 0 K. Or we can also take 3 common, minus I plus J. And now coming to the vector CA, CA vector is equal to OA minus OC. So from this both OA and OC, 0 minus of minus 4, that is plus 4I, 7 minus 9, that is minus 2J, and 10 minus 6, that is plus 4K. Or you can take 2 common, 2I minus J plus 2K. Now let's find the length of these vectors, side vectors. So mod of AB is equal to under root of minus 1 whole square plus minus 1 whole square plus minus 4 whole square, which is equal to under root of 1 plus 16, that is root 18. And similarly, the length of the vector side BC is equal to under root of 3 times, we can take 3 outside, minus 1 whole square plus 1 square plus 0, which is 3 times of root 2. And again, vector CA is equal to the length of the vector CA is equal to 2 can be taken outside, 2 square plus minus 1 whole square plus 2 whole square, which is equal to 2 times under root of 4 plus 4 8 plus 1 9, that is 3. So 2 into 3 is 6. And root 18 we can also write, root 18 we can also write it as 2 nines, that is 3 root 2. And here we can find mod of AB and mod of BC both are same, that is 3 root 2. And hence we can conclude that this triangle can be an isosceles. And also there is an option, fourth option, right angled isosceles. Let us check. 3 root 2 whole square plus 3 root 2 whole square, that is root 18 plus root 18 is, that is 9 twos are 18 and here also 18 plus 18 is 36. 36 is the square of the third side, that is 6 square. And we can also consider here mod AB square plus mod BC square is equal to mod AC square. So it is also a right angle triangle. And hence we can conclude the option right angled and isosceles, option D. Given two vectors, vector A I plus 2j plus 3k and vector B 3i plus 2j plus k, and here theta be the angle between them, then we have cos theta is equal to A dot B divided by mod A into mod B. So we can write dot product of these two vectors I plus 2j plus 3k dot product with 3i plus 2j plus k divided by mod A can be taken as root of 1 square plus 2 square plus 3 square, and mod B can be taken as 3 square plus 2 square plus 1 square, because we know that if vector AI plus BJ plus CK, then its mod can be taken as root of a square plus b square plus c square. So we can write here 1 into 3 plus 2 into 2 plus 3 into 1 divided by root of 9 plus 4 13 plus 1 14 into root of 9 plus 4 plus 1 14. So 4 plus 3 7 plus 3 10 upon root 14 into root 14 is 14. So we can write 2 5s are 2 7s are 5 by 7. So cos theta value is 5 upon 7, which is option A. Let us consider theta be the angle between two vectors, vector A and vector B. So vector A is equal to I plus j minus 2k and vector B is equal to minus I plus 2j minus k. Then we can write cos theta is equal to A dot B divided by mod A into mod B. So let us find A dot B, which is equal to I plus j minus 2k dot product with minus I plus 2j minus k. So we can add 1 into minus 1 plus 1 into 2, it's a 2, and minus 2 into minus 1 is plus 2. So we can add 2 plus 2 4 4 minus 1 3. So A dot B is equal to 3. And also let's find mod A is equal to under root of 1 square plus 1 square plus minus 2 whole square. So which is equal to root of 1 plus 1 plus 4, that is root 6. And again mod B is equal to under root of minus 1 whole square plus 2 square plus minus 1 whole square, which is equal to root of 1 plus 4 plus 1, which is again root 6. So we can write cos theta is equal to A dot B, that is 3 upon root 6 into root 6, which is 3 upon 6 is equal to 1 by 2. So cos theta is 1 by 2. Then theta is equal to, so here we can write cos 60 degrees, that is pi by 3. So theta is equal to pi by 3, or we can say angle between the two vectors is 60 degrees. So we can go with an option D. We need to find a vector of magnitude 5 and perpendicular to two vectors I minus 2j plus k and 2i plus j minus 3k. So let us consider vector A is equal to I minus 2j plus k and vector B is equal to 2i plus j minus 3k. And we need a vector which is perpendicular to this both and having magnitude 5. So we can write required vector can be 5 times A cross B vector upon mod of A cross B, because A cross B is a vector which is perpendicular to both A and B. So vector A, vector B, then A cross B is vector which is perpendicular to both. So let us find A cross B. The first row ijk, and the second row we can take the vector A components 1, minus 2 and 1, and in vector B the components in the third row 2, 1 and minus 3. Let us simplify. So we can write I times of minus 2 into minus 3, that is 6 minus 1, minus j times of minus 3 minus 2, and again plus k times of 1 minus of minus, that is plus 4. So which is equal to 5i plus 6 minus 3 minus 2 minus, so minus of minus plus 5j, and again 5k, that is 5 times of I plus j plus k. and mod of A cross B is equal to 5 times under root of 1 square plus 1 square plus 1 square, that is 5 into root 3. Hence the required vector is equal to, we can consider even plus or minus. So let us consider here 5 times A cross B, that is 5 times of I plus j plus k divided by 5 into root 3, or multiply and divide with root 3. So we get 5 root 3 upon 3, 5 root 3 upon 3 times I plus j plus k, which is our option A. So option A is the answer. Given vector A, vector B, vector C are non-coplanar vectors and lambda is some real number, then the vectors A plus 2 times B vector plus 3 times C vector, and second vector 0 times A vector plus lambda times of B vector plus 4 times of C vector, and third vector here 0 times A vector plus 0 times vector B and plus 2 lambda minus 1 times of C vector, and these three vectors are non-coplanar forward. So let us consider these three vectors will be coplanar if the box ABC into determinant of 1, 2, 3, 0, lambda and 4, 0, 0 and 2 lambda minus 1 will be equal to 0. But since ABC are non-coplanar, which means that box ABC, that is scalar triple product, is not equals to 0. Since it is not equals to 0, so this determinant must be equal to 0. So let us simplify the determinant. So 1 times of lambda into 2 lambda minus 1 minus 0, which is equal to 0. So we can write lambda is equal to 0, or 2 lambda minus 1 is equal to 0, which implies lambda is equal to 1 by 2. So we can conclude that for lambda is equal to 0 and lambda is equal to 1 by 2, the given vectors are coplanar. So for lambda not equals to 0 and for lambda not equals to 1 by 2, given vectors are non-coplanar. So we can go with an option. These are non-coplanar except two values of lambda, that is 0 and 1 by 2. Option C. Let's simplify I cross of j cross k plus j cross of k cross I and k cross of I cross j, where I, j, k are the unit vectors along the coordinate axis xyz. We know that I cross j is equal to k, j cross k is equal to I, and k cross I is equal to j. So here we can write j cross k is equal to I cross I plus k cross I, we can write it as j, so j cross j, and I cross j is equal to k, so we can write k cross k. So I cross I is nothing but 0 and j cross j is 0 and k cross k is 0. So we can give the final sum as 0, which is option D. And here I cross I is 0 because angle between the same vectors is 0 vector, and hence the sine 0 is 0. So option D is the answer. So we need to find the vector joining the points. Say the point A is 3, 1, 14, and the point B is -2, -1, -6. So we can mention like the position vector of A is OA is equal to 3i plus j plus 14 times of k, and the position vector of B OB is equal to -2i minus j minus 6k. And now the vector AB is equal to OB minus OA, we can write. So the vector joining these 2 points can be given by AB vector. So AB vector is equal to OB minus OA, which is minus 2I minus j minus 6k, minus of OA vector is 3I plus j plus 14k, which is minus 2 minus 3 times of I, and here minus 1 of j, minus 6 minus 14 of k, which is negative 5I, negative 2j, and minus 20k. So we can write AB vector is minus 5I minus 2j minus 20k, or you can also mention BA vector, the line joining the vector BA can also be taken, the negative direction of it. So minus of, we can write minus of AB vector, which is equal to minus of minus 5I minus 2j minus 20k, which can be taken 5 times 5I plus 2j plus 20k. So we can go with either plus or minus here 5I plus 2j plus 20k. So option D is the answer.